Welcome to Create Clarity, Don't Run Your Project Blind. I'm excited about this topic today. Hi, my name is Jeffrey Palermo, and I'm a chief architect at ClearMeasure, a full-service software architecture and engineering firm that serves companies that are building mission-critical software with Microsoft technologies. And so um, I'm really excited about this topic today, and this kicks off a five-part series around my new book, The Five Pillars Leadership for Effective Custom Software. And just to jump straight into the agenda, we're going to go over the success rate just of our industry to understand what we're dealing with, project sizes that are workable and get clarity on that, how to think about clarity on business objectives, our current state, where we're starting from, quality, achieving stability, and how to make our work visible. So we have clarity in what work we have before us and how fast it's moving. And all of this it can be found in my latest book, The Five Pillars: Leadership for Effective Custom Software. And it is available anywhere books are sold. You can go on Amazon.com and find the soft cover, the hardcover, the Kindle ebook version, as well as EPUB, and the Audible.com um, audiobook should be out imminently if it's not already published by the time you're seeing this. If for those of you who are not live listening to the recorded version of it. And if anyone has any trouble getting a copy and would like a complimentary electronic copy, I really want this book in the hands of anyone that's doing custom software because the stakes are too high. So just send me an email and I'll be happy to get you an electronic copy of the book if there's any hardship there. And also, it's several years old now, but more on the technical side. If anyone needs an electronic copy of the .NET DevOps for Azure book, you can send me an email to get that as well. And so we're going to be diving into clarity, which is the first of the five pillars. Internally, we call it the clear measure way, but um, it's really these five pillars for effective custom software. And we have some tools on our website. We have a assessment that you can take yourself. We have a team alignment template, which I'll talk about. We have a team scorecard, and you can find those on clearmeasure.com. Some upcoming things you may be interested in. We have our interactive forums. We have a software architect forum and a software leadership forum. The architect forum is for those who are in the team, in the code with your engineers and more highly technical topics. And the software leadership forum is for executives and management that are overseeing the software, maybe not necessarily so much in the code, but your job is to oversee a custom software team, and it's important that you're able to do that well. All right, so let's get into the material. What I want to talk about first is kind of sobering. It's not fun to talk about, but it's about the state of our industry. And just just in the last 10 years, I've highlighted some really, really expensive blunders that has happened in our industry, and it's fresh on our minds in 2024, the CrowdStrike outage where there was a defect that slipped through a channel which had very light, if any, quality control, but it was able to take down literally every customer's Windows computers because the bug was in the Windows version of their software. And it took down airlines and banks and businesses all over the world. And literally the only way to resolve it was for a person to boot up the computer in safe mode and twiddle some files. Literally every single computer had to be touched. And so, it says 2 to 24-hour outage, but there were some organizations that were still recovering days later. And the published impact has crossed $5 billion, but it's probably much greater than that because of the reported ones. And then in 2019, just a 14-hour Facebook outage had a $90 million impact. So software problems can, and these are just outages. These aren't even, we're not even talking about failed projects or projects that take too long. Our industry has a lot of challenges. It's really important that we take this seriously. And so the first aspect of running an effective software organization is having clarity in reality, how things are going, how are we doing, what are we doing? And so that's the first of the 5 pillars, which you can see on your screen. Go back. And um, in coming sessions, we'll talk about establishing quality and achieving stability and increasing speed and optimizing the team. But for now, um, we're going to focus on creating clarity, and that is around the business purpose of a software development project. Uh, and we need to understand what's being built, why it's important, how our team is doing, how effective are we currently, what needs to be improved, so we don't kid ourselves. We need to know reality. Okay. So the first aspect I want to talk about is getting clarity on workable project sizes, because not all projects are created equal. We have some data. The 2015 Standish Group Chaos Report gave us some really, really good data as it related to project success rates around our industry and and sizes. And so one of the themes in 2015 was the impact on Agile, and of course, um, Agile was found to be more effective than waterfall. But one of the surprising angles on this was not that, oh, Agile is better than waterfall, but it was how poor the track record of success for Agile projects that were very, very large. If you look at large project sizes, Agile, it's 18%. Yeah, waterfall was 3%. And so these really, really massive waterfall projects, almost all of them failed. And when I say failed, I mean not successful. When the people who approved the funding, whatever board of directors it was that was pitched this software project and a return on investment, and this is how much it's going to cost, and then it doesn't cost that much, and then the cost overruns and the schedule overruns. And if that group had only known what reality was going to be, they never would have approved the project in the first place. I consider that a failure. Okay. So this group that is challenged, that's the shade of gray, but but just look at that, and only 18% of Agile projects were fully successful. And the challenged projects, not that different between Agile and Waterfall for large projects. Then you have medium-sized projects. But what I want to highlight is small projects. Um, Even Waterfall had a 44% success rate for small project sizes and only an 11% failure rate for small project sizes. So the real story here, when you're thinking strategy, is how to break up really, really big initiatives into a series of small projects. You really want to think about just structurally how to make sure we succeed in software projects. Changing a methodology isn't a silver bullet, but it seems like breaking it up into small projects is, just looking at these numbers. Okay. So now, not a silver bullet because we still only have a 58% success rate, but it's the best number on the board. So we need to do a lot of other things, but we should absolutely not even be starting a project that falls into medium or large project size. Now, uh, what does that mean? Well, the small project sizes, and this isn't on the slide, but if the project can be implemented in roughly 50,000 lines of code, then it falls into the small project size. And if it's over 500,000 lines of code, then it's definitely into the large project size. So when you think about it, you can have some pretty darn significant software in 50,000 lines of code. Now, you could have that same software implemented in 100,000 lines of code if you don't have good design patterns, if you don't do any refactoring, and you just let the code sprawl. But I've been a part of and run plenty of software projects that had 50,000 lines of code where it it had quite a significant amount of functionality, very impressive functionality. So when you design it well, you can do that. So that's one thing to think about. And if you have some existing software systems that are 500,000 lines of code and larger, and you wonder why it's so hard to change and do a next version, well, it's not necessarily that um, the design or the architecture was just poor off the bat. It's letting it get that large is always going to be a challenge and almost like a recipe for failure. So one thing that you can do if you do have an existing software project that's that large and you want to do some modernization is find out how to split the system. Find out literally how to just carve it off and split it into two pieces so that both of them are not just twice as easy to work with, but probably an order of magnitude easy to work with. All right, the next thing I want to talk about is getting clear business objectives, and this is um, the purpose for why we're doing the software in the first place. Um, if everyone doesn't have clarity on the objectives of the business, then we can't all pull in the same direction. And this goes down to every individual working on the project, every developer, every analyst, every person who's configuring a server, every person who's doing any bit of work on the project needs to understand the business objectives of why this project was funded in the first place. After all, the board of directors that, again, heard the sales pitch for investing a big chunk of money in this software project, it was to accomplish some business objectives. And so that basically the charter, or you could think of it as the constitution of the project, and it needs to be taught to every person who's involved, so we can all align. Now, there's some kind of obvious ways to know if maybe you have some misalignment, and they're kind of on the screen. It's if there's some conversations in the development team, and um, in those conversations, someone says, we've already built our backlog. Now we're working to burn it down. Well, now we're kind of myopic. We're thinking about all these features and we're assuming that every feature has to be built. When really that's not the case. The next one is we already know the features we need. We need to get more development done faster. These are all required features. The subject matter expert has said that we have to have this feature. This feature still doesn't work the way the product manager wants it. There was I believe it was 2018 Puppet Labs industry survey where they really honed in on Scrum, which has the role of the product owner, whose job it is to decide what gets prioritized on the backlog. And this product owner is charged with being the representative of the business and kind of becoming somewhat of a subject matter expert. However, what this survey found is it doesn't actually happen that way. What they found is about a third of the features or changes that a product owner prioritized on the backlog were exactly needed and they helped accomplish a business objective. Another third of those items on the backlog, they were built, deployed to production. They didn't really move the needle on accomplishing the business objective. And then another third were actually harmful to the business objective and needed to be undone as soon as possible once they learned that. So through that, what we found is there's actually no substitute of really having a business person in the development team, just like the Agile Manifesto calls for. One of the 12 principles of the Agile Manifesto is business people and developers working together daily throughout the project. And this helps to make sure that everyone keeps laser focused on the business objective that we're trying to accomplish. Because yes, we're going to have ideas on certain features that could help us accomplish the objective, but if we put it on a backlog and then we call the backlog the definition of project success, we've already lost. The software team needs to be free at any point in time to challenge an item on the backlog and say, wait a minute, is that really necessary to accomplish the business objective we're trying to accomplish? It seems like this feature that we did a couple weeks ago seems like we kind of accomplished that, and that this one, yeah, it's some more functionality, but not really necessary. Can we just cross that off the list? And that's a valuable conversation to have. So, it's really important to have absolute clarity on the objective that the business is trying to accomplish. All right, one tool that we have at ClearMeasure available to you is the team alignment template, and you can find it on our website, clearmeasure.com. And it's a tool to make sure that everybody on the team is trained in the foundation for the project, the purpose, the business purpose that we were all gathered here to do, what we value, things like testing or quality or being able to deploy to production on a moment's notice, whatever is really important to the organization, and then a long-term and a short-term goal, a 1-year target, a little bit longer term, and then the current objective of the project, maybe monthly, perhaps. And then on the right-hand side, you see stakeholders, customers, and strategy. So stakeholders and customer, it's really important that we understand who the stakeholders of this project are, all the way up to the CEO, maybe the board of directors. Who cares about the success of this project? Do we know who they are? Have we ever spoken with them? And then the customers. Who's ultimately paying for this? Who are going to be the users of the software? And what is their story? What is their environment? And then the strategy overall. What's our strategy for executing this project? What's our plan for succeeding in this project, for accomplishing the business objective? If the objective of the project is to launch a new sales product into a new market or increase sales a certain amount, okay, what's our means to accomplish that? That's a strategy. And everybody in the project needs to be trained with these items. Everybody working any role in the project. And this template just is a nice, simple tool to help collaborate and make sure that we actually know and understand. And of course, the funders of the project agree that we understand. And then it's a tool to help train everyone involved in the project. The next point of clarity to make sure is that we understand our current state. How are we doing right now? And a tool that we have available for that is our scorecard. Now, status reports have long been a part of software projects and really any project for a long time, but the most ineffective status report is one that just has English sentences. We can report activity, we can report risks, but if all we have is English sentences, then we really don't know how we're doing. If you think about any kind of process that takes raw materials, takes some type of input, works on that input, and then produces some type of output, the process is not measured with English. The process is measured with numbers. And so it's important that when you provide a report on the status of a project, that it include numbers. And so this scorecard template is very, very small. It has very, very few numbers, but it has a few categories. The first category is about team alignment. This is all about business objectives. Even before you get into techie things, the business has some objectives that are trying to be accomplished, and there are some numbers that measure to what extent those objectives are being accomplished. Put those on the software team's scorecard so that we can know what impact we are making as a software project team. And then we have three other items to measure. These are the three middle pillars of the five pillars: quality, stability, and speed. And for quality, we suggest just the basics to get started. Now, more mature teams, you're going to choose to measure some additional things, but consider the items that we have in the template to be the absolute basics that every single software team should be measuring and reporting. Not knowing these items um, is not gonna engender success. You want to know how many defects are we catching? How many defects have escaped to production? How many uh, how many defects have been fixed or repaired? And how long does it take us to fix a defect? The mean time to resolution. This is the absolute basics when it comes to quality. With stability, we want to know, how many deployments are we doing per period, per day, per week, per month, per quarter? Because there's some good research from the Dora organization, which was recently acquired by Google. It's a research organization that shows that um, that software organizations that deploy to production more frequently ultimately are more effective and achieve greater levels of success. Now, that doesn't mean you have to do, 1,000 deployments a day, but if you don't even have the ability to deploy on a given day or a given week, well, then you're on the other side of the spectrum. But when it comes to stability, we want to know major production issues, minor production issues, and the mean time to recovery, or MTTR. These are the absolute basics for anyone who is running any type of software system in production. And the minor production issues, those are going to happen. We don't want them to be overwhelming, but we want to make sure they're resolved quickly. The major production issues are ones that end up being a business disruption. Somebody can't do their job because something minor either didn't get fixed quickly or turned into something major, which was a disruption. A minor production issue is not a disruption to getting business done. It's just something that needs to happen. We have an alert on there. Oh, we have one of the servers or one of the Kubernetes pods is running at 100% CPU saturation for an extended period of time. Hey, let's go check on that. That's a minor production issue. That's not immediately causing people to not be able to do their job. And then finally, speed. How fast are we going? How fast are we developing features? At the minimum, we want to know how many items we're delivering, how many features, how many changes we're delivering in a particular period, and how many items we have work in process or WIP. And that's a Kanban function. But this is the absolute minimum. And if you aren't tracking or reporting any kind of numbers for your software project, then this is a tool that you can pull down and use in Excel and just pull the numbers from your system. Some of your systems, might have will have some reports that give you some of these numbers. But either way, whatever format, and this is just Excel, simple. You want to be able to make sure that you're tracking your current reality. All right. The next thing we want to think about when it comes to clarity is knowledge of our current quality. Now, going through the scorecard, we talked about a few items for defects, but there's a next layer deep on quality. Um, in 2012, Capers-Jones published a paper called Software Quality Metrics: Three Harmful Metrics and Two Helpful Metrics. And one of the results of studying 19,000 software projects is that he found that out of 65 candidate defects, only 30 were defects that were caused by some problem in the code. So when we think about it, some people tend to make an assumption that if we have a bug, we have to get a coder to fix the bug. Now, ultimately, to some extent, you will at some point. But the assumption then is, oh, if we have a bug, then it was a problem with the code. The code wasn't written properly. And that's actually not the case. 30 out of 65 is less than 50% of defects are attributed because the code was written poorly. What Mr. Jones has found across 19,000 software projects is a little less than a third. 20 of those were some bad design decisions. 10 of those were some analysis gaps or some improper assumptions or decisions when thinking about what the requirements of what the software should do. Three of them was in documentation or supporting material, and then two of them were caused by fixing other defects, and they were bad fixes. So when you're thinking for yourself how you're doing on quality, keep this in mind and make sure your process has some ability to report or count for yourself what the cause of those defects are. And you want to make sure that you also have some mechanism to count implicit defects. If you have a Kanban board, like sample here, which we'll talk about in a minute, and a card has to go backwards in the process, that really is because there's a problem in that stage. And if the card has to go backwards in the process, well, that's a good thing that we found out a problem. Well, that's a defect. And it needs to go backwards to whatever column where there is incomplete work. Um, the if a particular card moves to a column and it's not yet ready for that column, that means that some work that was supposed to be done up to that point is not done. Well, that's kind of the definition of a defect, right? So that's another concept to make sure you have in your process is the ability to know and count defects that didn't make it to code or defects that didn't make it to a manual test environment or to production, where you just kind of found it in line and team members moved it backwards in the process. And always with defects, you want to make sure that you have a complete DevOps environment. I'm not going to go into detail about this on this particular session. We have quite a few other sessions that go deep into this. This is part of our DevOps architecture poster. And of course, if you don't yet have a high resolution PDF copy of our DevOps architecture poster, then you'll definitely want to get it from us. All right, next topic is clarity on how to achieve stability. We want our software to be absolutely stable in production and doing what it's supposed to. There's a whole lot of parts of stability. You could say reliability, fault tolerance, scalability. There's a whole bunch of these non-functional requirements, but really stability can be summed up in just the assertion that it should continue doing its job without interruption in production, serving its users. And certain bad things that happen, if they can't be handled and the system no longer is serving its users, and we have business disruptions, well, now that's a lack of stability. If you haven't ever watched the History of DevOps, a video by Damon Edwards, I highly encourage you to read that because there's so much on live site operations and how to get changes to production in a very stable fashion and how to keep systems absolutely stable. And the interesting part is the mindset because Damon Edwards goes through the story about how DevOps was originally going to be called Agile System Administration. That originally there was a whole lot of great advances going on for developers in the Agile movement, and sysadmins were still doing everything manually before cloud adoption, and still in the cloud, there's a lot of sysadmins doing things manually. But Damon was interested in applying all of the great automation that developers were figuring out with the agile mindset, and when he wanted to apply that thinking to system administration. And then, of course, through the process and some conversations and community conferences and other suggestions, there was the name of DevOps that kind of won out um, by some people uh, who were saying that Agile System Administration was a boring name. But if you just translate that in your mind, the four values of the Agile Manifesto and the 12 principles, and DevOps is all about applying that thinking to system administration and how we run our systems, then that can help us craft a strategy for achieving and maintaining a high level of stability in our production systems. Next thing we need to think about and make absolutely clear to everyone involved in the project is the work that is in front of us. All work needs to be visible. And this is where I come back to our sample Kanban board. And it's important that every every type of work and every station of work be sequenced in the process and set up this way in our work tracking system. So it's absolutely clear how many items of work are in each stage. When you spin up a board with Azure repos or Jira or GitHub Actions, a lot of the times you just have a board that is basically not started and then in progress and then done. This doesn't tell us anything. It might as well just be a checklist or a task tracker. But that's woefully inadequate for the software development lifecycle. And the stages in the software development lifecycle have been pretty stable for a few decades. It's just that the agile movement changed the batching. Instead of batching up a whole bunch of features in a particular activity and doing a whole bunch of requirements analysis and then doing a whole bunch of user design and a whole bunch of technical design. Instead of doing that, Agile moved us to a single piece flow where we do all the activities for one feature and get that feature to production. And we flow through features independently from each other and try to limit the work in process. Okay, but that the stages are still the same. And you can add your own flavor to it, but the stages are the same. The old requirements analysis, that's the concept definition column. That's where that's what we're really thinking about. We're really thinking about why why are we doing this? What is necessary? What is the concept? What should be a feature? What should be a change? And we're really doing analysis and thinking about that. Then, once we have confidence, we move to thinking about how a user is going to use that bit of functionality or experience that bit of functionality. If there's a screen involved, well, sure, we need to make a wireframe so that we kind of design and decide how that screen is going to be shaped, how many fields on that screen. Maybe the feature is just, moving data in the background from point A to point B, but it's still a user experience design decision on whether the data needs to be near real time or get there really quickly within a few seconds, or if it's okay for the data to take 6 or 12 hours to move from one place to the other, or a report that refreshes, every 12 hours versus every 12 seconds. Those are all decisions about how a person is going to experience this software feature or change. And then once we make those decisions, we decide technically, how are we going to implement this? This is technical design. How is it going to be made to happen? Libraries, design patterns, architectural elements, things like that. And this is where we also start breaking it up into implementable chunks. And this is where we have visibility where, okay, we're not gonna implement it as one fell swoop. Maybe we need to implement, chunk A, chunk B, chunk C. And it's a series of software changes that ultimately make this new feature possible. Then after that, we design some tests. We figure out how many unique pathways of behavior does this new functionality uh, create, and how many test cases do we need? How many unique ways will this new feature in the software behave? And let's make some bullet lists so that we don't leave it until after the fact to think about what behavior scenarios need to be tested. And armed with those four design decisions, developers can actually go pretty fast. Developers can take a chunk that has been broken out in the technical design column and get that chunk done within a day, get it code complete within a day. Now, if you have something where, hey, we don't have any idea how we're going to implement this and we need to do some research and shoot, I may spend just a couple days experimenting and figuring it out. Well, that's not development. That's actually technical design. If we don't know how we're going to implement it and we need to experiment with a few things and do some research, well, that just means technical design is going to take a little bit longer because in order to actually decide how we're what a workable design is, yeah, I need to spend some more time on this and do some research and doing some experimenting. But that's clarity into what work we're actually doing. If we don't have all of these columns in our work tracking board, and by the way, I don't care what you call them what you want, but these concepts need to be there. If we don't have them there, then we may be doing research or design experimentation or learning. And if the feature is sitting in the development column, well, and the rest of the project team and the rest of the organization thinks that we're actually doing software development. We're actually doing coding. And we're really not. We're not ready to actually write the code for a particular feature because we don't yet know what the workable design is going to be. We don't know if a hypothesized library is going to do the right job. So it's important that we have all the appropriate columns on in our work tracking system and that we use them so that it's absolutely clear where the work is. And this will let us populate our scorecard with where additional metrics for bottlenecks and how many items are stuck in which column. And do we have one column that just has a backlog and maybe we only have one person working that column, where maybe we need to reorganize our team and allocate more manpower to an upstream column that's just falling behind. And then, of course, after the development column, after the column where we actually write the code to make features happen, we have functional validation, which is testing within the development team, and then user experience validation, which is your manual testing, oftentimes at the product management level outside the development team. And then release validation is the final, make ready, is it ready to go to production, check on those things, and then we go to production. So it's very important that we have visibility to all the work and clarity into what work is getting done and how much. A tool that we have available is the Software Leaders Handbook, and you can find that on clearmeasure.com, but it also has some additional principles that dive into this, and that's available to you. All right. I know this is a lot of information, but this was just a overview of creating clarity, which is the first pillar of the five pillars. We will follow up with establishing quality, achieving stability, increasing speed, and optimizing the team. But this is just the first one, and is so important that you actually create clarity up and down the organization. If you When you're trying to tackle quality problems or stability problems and you still don't have clarity, um, it's just a frustrating situation. So I do encourage everyone to get a copy of my latest book, The Five Pillars Leadership for Effective Custom Software. And the entire first part of the book, nearly half of the text, is lead ups to creating clarity and understanding what the reality is in the software industry and within our organization, and what tends to work and what tends to not work. And so um, we have a book study guide that is coming out that will enable you to facilitate a 7-week book study, one session per week, to not necessarily study the book, but to study your team, to really do a deep dive into your team, into your software, into your project, so that you can get better as a team. And so we make that available. The If you're interested, let us know about the study guide. It is almost completely finished with spit and polish, and that'll be available to you as well. So thank you so much for attending this session. Really appreciate it, on creating clarity, the first of the 5 pillars, and we're excited to do the other sessions in the coming weeks. So thanks so much, and God bless.